The topic of my experiment is Flowing into the Future, addressing urbanization's impact on water quality in the Chesapeake Bay. The impact of urbanization on water quality in the Chesapeake Bay area is investigated in this study. The hypothesis is that water quality deteriorates with increased urbanization. A novel approach is used to collect Earth observation data from Landsat 8 satellite and Copernicus global land cover layers to mark the land use. Total suspended material is calculated from the EO data, and population data is also gathered. The motivation for this research work stems from the rapidly growing global population and the increasing percentage of people without access to clean water. Specifically, with references to the Chesapeake Bay, the thriving military, harbor, and environmental industries in Hampton Roads support its 1.6 million residents with some recent rapid urbanization. The equipment typically used to measure turbidity can be quite costly, and this high cost is a roadblock for many projects, particularly in developing countries. In this project, a renowned GIS-based algorithm is used to calculate the TSM values. The algorithm and its formula are shown here. The research question is, how does population and percent of urban build-up land influence the water quality in the Hampton Roads area of the Chesapeake Bay? The expected outcomes are, some water bodies will have less TSM values than others and will prove cleaner than others. The null hypothesis is, there is no significant relationship between population and percent of urban or build-up land with the concentration of TSM in water bodies in the Hampton Roads area of the Chesapeake Bay. Its alternative hypothesis is shown here. There are two independent variables, population and percent urban or build-up land. The dependent variable is TSM. Constants are listed here, and the control is the first experiment set in 2016. Here is the procedure. 7 cities were studied: Chesapeake, Hampton, Newport News, Norfolk, Poquoson, Portsmouth, and Virginia Beach. Open Data Cube and Python Notebook were used for analysis. Analysis involved loading Landsat 8 and Copernicus data, calculating percent of urban land pixels, and outputting CSV files with yearly population data for statistical analysis. There was no risk involved in this work. This is the area of interest. This is a median composite false color image. A shapefile is applied to filter out the 7 cities. Here is the land classification from 2015 to 2019 from the Copernicus land classification data. The pixels in red are urban or build-up areas. We have the population data as well as the overall GIS data for analysis. Estimated population is according to the United States Census Bureau. It is important to note that these are only estimates and the actual population numbers may have varied slightly. These plots show that there has been a slight decrease in the total population, a steady increase in the percentage of urban or build-up land, and an overall increase in water pollution levels, as indicated by the mean TSM concentration. The multilinear regression was applied to the data. The coefficients of the model as well as their respective p-values are presented here. In conclusion, it's important to note that although the model is significant, that is, urbanization affects water quality, it does not necessarily imply causation. Other factors that are not included in the model may also be influencing the TSM. Therefore, the results in this study should be interpreted with caution. The data used in this analysis only covers a period of 5 years. It would be interesting to see if the relationship between the independent variables and TSM remains consistent over a longer period of time. Here are the references. Thank you.